Hello everyone, welcome back to episode 4 of What's Inside. Today we'll be going over something quite fascinating. I think this is going to be a pretty cool episode because we're going to be going over
The DHT11, which is a single wire chip here, and it collects the temperature and humidity sensors.
Yep, and as you can see, there's just 3 pins and three pins for it to connect, and of course, temperature and humidity sensor itself, which is in blue. It kind of looks like a grid right here. Now, let's get into analysis.
Hey everyone, welcome back to the analysis section of this DHT11 temperature and humidity sensor piece. So why does it actually matter? And so this piece is a compact, low-cost digital sensor that gives both the temperature and humidity data in a single reading. And so some of the key features, it has a numerous amount of features, but it has digital output, so there's no analog to digital conversion, internal sensor fusion and calibrated signal. It works with just one data pin. There's 3, but we just need 1. It's fully encapsulated and portable, easy integration with microcontrollers like the Arduino, ESP32, Raspberry Pi. And although it's pretty simple, this module integrates multiple sensing techniques and timing critical communication in this very small piece.
And now let's get into the functional block diagram. So for each subsystem, there's a specific role that it plays. So for example, there's a capacitive sensor, which measures relative humidity. There's also a thermistor, which detects temperature in Celsius. Also the ADC converts analog readings into digital data. As well the MCU, which formats and sends the data as 40-bit digital packets. And then there are also pull-up resistors, which are used externally to maintain a high data line.
And let's get into the blue sensor, which holds the temperature and the humidity stuff. So the blue casing has these little holes, which are the ventilation holes to allow the air exchange between the outside and the inside of the chip. And inside we have the capacitive RH sensor, which is a polymer layer that absorbs moisture and changes its dielectric constant, which will give you this humidity reading. And then we have the NTC thermistor, the resistance changes between temperatures. The CMOS chip converts these readings into digital 40-bit data. And finally, the ASIC microcontroller, it handles the measurement and communication protocol.
Now, let's get into electrical characteristics of this thing. So, for the voltage needed to operate it, you need somewhere around the range of 3.3 to 5.5 volts. And for the temperature range that is effective at measuring, somewhere around 0 to 50 degrees Celsius. And this temperature is accurate to a degree of plus or minus 2 degrees Celsius. And the humidity range is from 20 to 90% relative humidity. Humidity accuracy is plus or minus 5% relative humidity. And the sampling rate is 1 reading per second at the very maximum, while the current draw on average is 500 microamps, deciamps. And the data format is a 40-bit burst, which is in 5 bytes. This sensor isn't very ultra precise, and it isn't very fast either, but it works and it serves the purpose for DIY or any prototyping applications.
And then moving on, so we have a couple of pins here. We have 3 pins. The first one is the VCC, the power, which is a range of 3.3 volts to 5 volts. Then we have the next one, the middle one, is the data pin, which it serves the purpose of bidirectional signal or open drain. And finally, the last pin is the NC, which just means not connected. And you must add a 4.7 to 10K omega pull-up resistor. From data to VCC to keep line idle high. Data line is open drain and pulled by sensors during communication.
And so there's a lot more that we could cover in this little piece right here, such as the communication protocol, the data format, bit timing, Arduino implementation, just so much stuff to do. But as always, we'd always be here for hours and hours, which I could too. But if you also have any questions, just send us an email at learnwhatsinside@gmail.com. But yeah, that's it for today's episode. Hopefully you enjoyed. Hopefully you learned something too, because this thing makes a lot of things possible. Really cool, and there's a lot you can do with it. Thank you for tuning in. As always, remember, it's always stay curious because that's what's inside.